Okay, so on this particular problem, normally I wouldn't read the entire problem because you all have just read it. But I am going to talk about, I'm going to read through it just a little bit or summarize it because the question does refer to parts of it in the question stem. So first off, they're trying to determine how far a golf ball can go, and they tell us it cannot exceed 291.2 yards. And they want to, and this particular manufacturer has created one with a standard deviation of 2.8. All right. And they also tell us here that it's normally distributed. And that's really important because that lets us know that we can work with a normal curve. So if the manufacturer sets the mean distance traveled to be equal to 288 yards, what's the probability that a ball that is randomly selected for testing will travel too far? Now, one thing I haven't shown here that I highly recommend that you give, because a lot of times they give partial credit, and the reason I haven't shown it is I don't have a good way to draw this, is the normal curve. So in this particular case, you have a normal curve. We know this manufacturer set the mean distance at 288. And we know that traveling too far occurs at 291.2. And they specifically asked, what's the probability that a randomly selected ball travels too far? So I'm looking for this area right here, my shaded area. So I need to define my variable. So x is the distance traveled by the ball. Since I'm working with a normal, I went ahead and wrote this down. I just always do. So I want the probability that x will be greater than 291.2. This is what I'm looking for. I plug into the formula, and all I'm doing is plugging in my x of 291.2, my mean of 288, and the standard deviation from above of 2.8. And then I'm going to just go ahead and do the rest of this work using the calculator. Now, there's two places you can go to. And I'm going to show you how to use the stat test because I think that's going to help you out because it immediately gives you both the Z and it also gives you all the probabilities. So it gives you all the information if you just work straight with the stat test. So stat test, we can go to Z test. My mean happens to be 288. Well, just a moment. My mean is 288. My standard deviation, in this case, is 2.8. And I want it at 291.2. Now, here's what's interesting. It asks for the sample size. We're looking for the sample. We are looking for the probability that one ball travels too far. So my sample size is 1 in this case. All right. So we're going to put a greater than symbol. And we go calculate, and we find out that we end up with a Z statistic of 1.143, a probability of 0.127. And so that right there tells us our answer, that the probability is 0.127 that the golf ball will travel farther than 291.2 yards. And that, if you did that, would get you full credit. One of the things, if you read their notes on it, is they ask to tell that it's a normal curve. And I specifically did not do that. However, by having this drawing, that takes care of it. Also, if I use this and calculate the probabilities, that does as well. Can I ask y'all something? Are y'all getting a bunch of feedback or something? I have no idea what's causing it because it's quiet in where I'm at, but I'm getting a weird reading. I'm going to adjust the computer location so that maybe that will impact the mic just a bit. I don't know. The next one, that seems better, just that distance. Assume the mean distance traveled is 288 yards and that 5 balls are independently tested. What's the probability that at least one of the 5 balls will exceed the maximum distance of 291.2? Well, as soon as I say at least one, I immediately think I'm working with a complement. I think of 1 minus. I also know I'm hitting exactly 5 balls. So I have a fixed number of trials in 5. So what satisfies my interest is I have 0, 1, 2, 3, 4, 5, because I have 0 balls go too far, 1 ball, 2 ball, 3 balls, 4 balls, or 5 balls. So this goes too far. So the 0 is the only one that doesn't. So I have a fixed number of trials. We calculated the probability that any one ball travels too far up ahead in part B, part A at 0.127. So we have a probability. So what I'm looking, this makes this a binomial because I have a fixed number of trials, a fixed probability, and a fixed number of successes. So I have 5 choose 1, 0.127 to the first, and then this is just 1 minus the 1, this right here is 1 minus 0.127, and then plus plus 5 choose 5, do the same thing. Okay, now for the calculator purposes, or actually for work shown as well, I can subtract out what I don't want, which is 1 minus the probability of 0. And that's actually the way I'm going to approach this on the calculator. All right. So otherwise, I have to do a sum of the PDFs of 1, 2, 3, 4, and 5. So here we go. 1 minus second vars. And anytime I'm working with multiple values, I use a CDF. And by the way, the CDF of 0 and the PDF of 0 are the same. So I could have used a PDF, but since I'm working with multiple values, I use a CDF. But 1 minus, but either one would have given you the correct answer in this case. So 1 minus binomial CDF, trials is 5, my p-value 0.127, that was what we calculated in part A, and this is 0. So I end up getting 0.4929 is my answer. I rounded it to 0.493, but we could have just left it as 0.4929. So the probability that at least one of the 5 balls travels farther than 291.2 is 0.493. Context. That's a really good question. In past years, they have not been big about taking off for it. So if you just wrote 0.493, they gave you credit. However, I've been watching the College Board presenters, and they keep saying, write that sentence. So please provide context, just like I did in the first one, do it here. Do I think they will count off for it this year? Probably not. But when the College Board presenters, the ones that College Board has hired, says write the context sentence, I wouldn't take a chance and get a partial credit on something that I knew the work for. So please go ahead and make sure that you give a context sentence. All right? All right, part C. If the manufacturer wants to be 99% certain that a randomly selected ball will not exceed the maximum distance of 291.2 yards, what's the largest mean that can be used in the manufacturing process? So here, I know that I cannot, I have a normal distribution. I know I cannot exceed 291.2. I don't know my mean. This is what I need to find. But I know this area right here is 0.99. Once again, they love these little drawings. They're easy to do. They're good. They help you out, but they love those little drawings. They make up for a couple things that you may accidentally leave off. So once again, I know I'm working with a normal, so I write this formula and I start plugging in what I know. Well, I know 291.2, I can't exceed that. I know my mean, I don't know my mean, but I know my standard deviation. But the question is, where did I get this value from, 2.326? And I got that value based on the fact that they said that I could not exceed, that 99% had to fall below. So that came from the 99%. You don't have any work to show on that. You just go to the calculator, second vars, inverse norm. The area is 0.99. And the reason you don't have to do anything, you don't have to subtract and divide by 2, you don't have to do any of that because it's a percentile And percentiles always go from negative infinity to that percentile level. So they're always going left to right already, so you don't have to do anything. Whereas on a confidence interval, you have to divide by 2. So mean is 0, standard deviation of 1. And I get 2.326, and that's my z-score. So, all right. So because this, and this is actually should have said 0.99, not 2. So this goes over here. Now I have 2.326. And I can solve by algebra. So 2.8 times 2.2326 plus, or excuse me, minus 291.2. When I do that, I end up getting 284.686 as my answer. Okay? So the mean, the largest mean that can be used for the golf ball flight is 284.6 or 284.7. If you round, either way is going to be fine. And that should be my mean here. If I have anything greater than that, it's going to travel too far. Now, the one that I asked, which is why I highlighted it so you know that it wasn't part of the College Board questions. It says, assume that the manufacturer has set the machine so that the mean distance, and here, this is the key phrase, that the mean distance traveled is 288 yards. If the manufacturer tests 5 randomly selected balls, what's the probability that the mean distance exceeds the distance of 291.2? So I'm going to go back to my little drawing, which I haven't made yet. But now instead of working with an individual value, I still have the same mean over here of 288. This is 291.2. We can't exceed it. This is no longer x, this is x bar, and I want to know the probability that I end up with that. So x bar, and I didn't write the formula, I'm ashamed of myself just now looking down that I hadn't done that. My formula would have been this. Z equals x bar minus mu sigma divided by square root of n. All right, so I should have included that. I plugged in 291.2, that's the distance I can't exceed. 288 is the mean that's given. This is 2.8 divided by the square root of 5. So once again, if I go back to the z-test, stats test, z-test, 288 is the mean, 2.8 is our standard deviation, 291.2, that's our x bar, that's the distance that we can't have an average, but now we've just changed our sample size to 5. And that probability is 0.0053. So I end up with a z-score of 2.555. So the probability that that z-score is greater than 2.55 equals 0.0053. Okay, like I said, I should have written the formula. If you didn't and you show your plug-in, that's fine. The problem is, and Ms. Lamb and I were actually talking about this before we all signed on this morning, is that if you just showed your plug-in numbers and you have an error there, then you're going to get it wrong for having the wrong answer, and you're going to get it wrong for you haven't shown the formula that you know the formula. So consequently, instead of getting partial, you would get an incorrect. Now, if you had written this and these numbers had been wrong but had been reasonable, you would have gotten partial credit. So it's really important to have that formula, which is why I was dismayed to see that I had not included it. All right, I'm going to pause the record here